Now let's find the value of this integral. Here I see that I have the square root of x cubed minus 12x plus 16. The issue is the square root. If we don't have the square root, this is just a polynomial and we can do it very easily. So the issue is coming from the square root. Okay? In this case, we try to factor out this polynomial and we get rid of the square root. And one key idea is to see this is a polynomial of degree 3. We try to see if there is a solution, and I can see that there is one here. If I see that 2 cubed minus 12 times 2 plus 16 is giving me 0. That means 2 is a solution. Okay? So if 2 is a solution, I can factor this one, the polynomial. I'm not worried about the square root now. The polynomial, I can factor it as x minus 2 times ax squared plus bx plus c. And I can work the problem. I can find a, b, and c. How to do this? I expand everything and I multiply, cross multiply and expand. And I'm gonna get this polynomial. It will become a order 3 polynomial. I'm gonna take I'm gonna identify the coefficients of this polynomial with this one. When I do so, I will get a is 1, b is 2, and c is minus 8. Okay, I did this one in a separate piece of paper. So when I do this, I get x cubed minus 12x plus 16 is x minus 2 times x squared plus 2x minus 8. Now we can factor this one here. I can use the discriminant, or I can do just x squared plus 2x minus 8. I add and subtract 1. So when I do and add or subtract 1, minus 1 plus 1, I get x plus 1 squared minus 9. And if I multiply and if I factor out again, I'm gonna get x plus 1 squared minus 3 squared. I'm gonna have x plus 1 minus 2 times x plus 1 plus 3 here. So I'm gonna get x minus 2 times x plus 4. And I go back here, I'm gonna get x cubed minus 12x plus 16 is gonna be x minus 2 squared times x plus 4. Okay, now if I go back to my integral, it's gonna be x cubed minus 12x plus 16. It's gonna be here, the square root of x minus 2 squared is gonna be x minus 2, and I will be left with x plus 4, between 4 and 5. Now to get rid of the square root, I'm gonna use a change of variable. Let u be the square root of x plus 4. I will change the upper and lower limits. Here, the integral will be between, when x is 4, u is going to be square root of 8. When x is 5, the u is going to be 3. And I need to change x minus 2, and this one is u. And I need to find dx. du is going to be 1 over 2 square root of x plus 4 dx. And this is just 2u. So I have 2u, du is dx. Okay, so I'm gonna change these two here. So I have square root of x plus 4 is u, and dx is 2u du. So I have 2u squared du, and I need to change this one. To do so, I need to square. I'll square u squared is x plus 4, and when I do, I need x minus 2. That means I need to add 6. U squared minus 6 is x minus 2. So x minus 2 is u squared minus 6. Okay, and therefore I have a polynomial here now. So I'll take the 2 outside, and the integral is gonna be between the square root of 8 and 3 of u squared minus 6 times u squared du. Okay, and this is a polynomial that I can work a bit. So I get u4 minus 6u squared du. So I'm gonna get 2u5 over 5 minus 6 over 3u3 between square root of 8 and 3. And we can simplify this more, but we can evaluate. But I'm gonna stop here. I'm not gonna do the evaluation, assuming that my computation is right. And this is gonna be 2 if you simplify. And I'm not gonna compute this one. The aim is to find a primitive. Okay, we don't need to go and change u for the square root of x plus 4. No, we just evaluate the values and we're gonna get the same values. Okay, and I think that's it. I'm not gonna evaluate this one. Thank you.